Hey again, it's Horner, and we're going to look at the 2004 M1 free response. So this is mechanics, and it's number one. You got another pendulum going on here. So person is sitting on top of a cliff. They kind of slide off. They hold on, and then they swing down. They grab this rock, and then they both fly down into the water. So they want us to go through and then they want us to find here the speed of the person just before the collision with the object. So to do that, they also want to make sure that we're doing this in terms of M1, which is the person, M2, which is the object, L, the length of the string, and G. So this one's pretty easy to do. We just have to think about conservation of energy. So at the top, we have potential energy due to gravity. At the bottom, we have our kinetic energy. So here, this is kinetic energy, 1/2 m1 times the velocity at point B squared is equal to the mass of that person again times gravity times the length of the rope. And so now we can just say that the velocity at the bottom is equal to the square root of 2gl. There we go. It's because these masses cross off. So pretty easy to do. You get 1 point for each thing. And so that one is super simple. The tension in the rope just before the collision with the object. We've kind of done this before in the last problem. So we have to remember that there are two forces acting on the person. We have the tension and we have gravity. We also know that this is going in a circle. So remember, for this one, we're going to have to say A is equal to V squared over R, which is really V squared over the length of that rope. And so now we can say that, well, let's go ahead and draw this just in case. So there is the person down on the bottom. We know that we have a force down, which is mg. We know that we have a force up, which is the force due to tension. And we know that this thing is accelerating with a centripetal acceleration. So we're going to take T minus m1g, and that is equal to the mass of the person times the acceleration, but we said acceleration is v squared over L, so this would be v squared all over the L. Okay. So now we need to solve this for t, so this is going to be mv squared all over L plus mg. And both of these m's here are 1s because it is of the person, so we will do that. Next thing we need to do is we've got to substitute in for that speed that we had from up above. So remember, our speed here is 2gl. So now we're going to say t is equal to m1 times 2gl, and that one is squared over L, and we're going to add to that the m1g. So now at this point, what we're going to end up with is basically we've got m1 here. We have 2 times 2, which is going to be 2 squared is 4. Oh, but you know what? Hold on a second. If we come back up, notice that VB is equal to the square root of 2GL. So 2GL, we don't really need, when we square it, we're actually squaring the square root of 2GL, which makes it a lot easier because now you can get rid of the square and you can get rid of the square root. So forgot about that part. Now we have an equation that's a lot easier to work with. We see that the L's cross off, so the length of the string does not matter, which is really super strange, I know. And then we've got 2 m1g plus m1g, so that's 2 m1g plus m1g, and so now the tension is just equal to 3 times m1 times g. Really strange how you get that, and it's kind of hard. You have to kind of it's somewhat perplexing. But it really does work out. So here you get a point for this acceleration. We do get a point for the two forces. So as long as you have this equation and you have the two forces there, you get that. Then we've applied Newton's second law because we said that the sum of the forces are equal to m times the centripetal acceleration. So we did that when we wrote the equation. And then the last point that you end up with here is for having the t is equal to 3m1g. Next thing they want us to do is find the speed of the person just after the collision. So we know that this is an inelastic collision. We've got m1 times the velocity of this person is equal to m1 plus m2, and we'll multiply that times the final velocity. So our final velocity is equal to m1 over m1 plus m2, so that's a total mass times the velocity of b. But earlier we said that our velocity of b is really 2gl, so final velocity is equal to m1 over m1 plus m2, and then we're going to multiply that times the square root of 2gl, because that is what velocity is, because well, that's what we were given. So anyway, 3 points there, so 1, 2, and 3, and that is letter C. For the next part, this is letter D. They want us to, in letter D, find the ratio of the kinetic energy for the person-object system before the collision to the kinetic energy after the collision. So we'll do all that in this little space here. So this is the potential energy initial is equal to 1/2 of m1 VB squared. That is actually equal to 1/2 times m1. Remember, v is the square root of 2gl, so v squared is going to be just 2 times g times l. Put that in parentheses. So that's equal to m1 times gl, because the 2's get crossed off. Now that we've done that, we can find the final kinetic energy. That is equal to 1/2. Remember, we add the two objects together, m1 plus m2. We need to multiply that times the final velocity squared. So that is equal to, now here we go, 1/2 of m1 plus m2, 1/2 of m1 plus m2, and then we have to multiply that times our VF squared, which we said was m1 squared over m1 plus m2, and we have to square that because remember it's squared, and then we're going to multiply that times 2gl because it was the square root of 2gl. And so now when you do all of your math, you should get, you'll see that you've got one of these is going to cross off with this one, the 2's go away, and we're left with m1 squared over m1 plus m2, and that quantity times gravity times the length of the string. So now we still haven't done the ratio yet. We need to do the ratio. So this is the kinetic energy initial over the kinetic energy final. And so this is going to be equal to mgl over, and then you've got m1 squared times g times l over m1 plus m2. And once you've done that, if you go through, you can cross off a g, you can cross off an l. We can cross off one of the m's, which is this one. So now you can take this and put it on top by doing the reciprocal. So this is equal to m1 plus m2, and then that whole quantity divided by m1. So that is the ratio of the kinetic energies. No velocity at all there, which is very unusual, but that is the way that the math works out. So let's go on and take a look at the very last part. So for this one, what they would like for you to do is find the total horizontal displacement of the person from A until the person and the object land in the water at D. So first thing we can do is just say that the L is equal to, so that's the height, is equal to 1/2 of gt squared as long as there's no air resistance. And we know that that position of those two objects, so we're going to say that is B and D, is equal to the velocity final times time, because I know velocity is equal to change in position over change in time. If we take that first equation and we go through and solve for time, so time is going to be equal to the square root of 2L all over G. So that's this equation. We've solved it for time. And so now we're going to plug everything into this equation. So this is XBD is equal to the final velocity times time, which is equal to, and yes, we got to put this in again, m1 over m1 plus m2, m1 plus m2 times the square root of 2 times gravity times length, and then we have to multiply that times what we have for time, which is the square root of 2 times L over G. Now that we've done that, we can go ahead and simplify. When you simplify, you should get 2 m1 times L all over m1 plus m2. We know that the total displacement from A to D, so if I want to go from A to D, that is equal to the distance that we just did, XBD, plus L. So if we're going to do that, let's go ahead and plug everything in. So we've got XBD is this, so that is 2m1L over m1 plus m2. And then we need to add to that another L. So our total distance is going to be equal to 3m1 plus m2. Because we have to have a common denominator, we had to multiply the top here by m1 plus m2 and the bottom by m1 m2. And then we're going to take that, and that is times L, that quantity times L over m1 plus m2. And now you are done, because now we found the total distance from position A. So we're going to go all the way back up here, from A all the way across. So from B to D is the first distance that we found. Then we had to add this part for A, but notice that that A part is equal to L. We don't know what this is, but we did find it by using our equations, and now we are done. So remember, BD is just from that second part where they're together all the way down to the ground, and that is the end of what we're going to do for the 2004 problem.